Howdy guys. In the following 2 weeks, we will design Lab8 and including the next PC logic and the register file. For the next PC logic, you need to design that based on this diagram. And you can find this in the pre-lab 9, also in the textbook. Okay, so for the next PC logic, okay, this is the current PC. And the current PC will go two paths. One is add 4, and one is add the output of the sign standard. There is, you can notice that there is a shift left by 2 here for the sign standard output. But actually, I have included this design in the sign standard design. In the sign standard for the B tab and CB tab, I add a 2 base 0 at the end of the output of these two type of instructions. So that means I have done the shift left by 2 in the sign standard. So you don't need to do that in the next PC logic. And these two paths will go to a 2i max. And for this 2i max, the select signal is a combinational signal. And unconditional branch go to the OR gate, and branch and ALU will go to AND gate. The output will go to the OR gate. And for the 2i max, the output will be the next PC, and next PC in the next cycle will be the current PC, and just the for the cycles. Okay, so for to design the next PC logic, first you need to follow the path, and for second, with for the any additions with the constant should have a delay of 1, and general addition should have a delay of 2, and multiplexer should have a delay of 1. So when you design this, you need to just calculate the delays for the two paths. Yeah, and just you can check your site standard design if you have just followed my last intro video to add 2 bits shift left 2 bits in the site standard design. Okay, and next one is the register file. First, for the register file, you can see the diagram. And this 32 times 64 bits is the register. We will save the data inside. And to declare the register file, you can do this to declare the 32 times 64 bits registers by here, by this. Okay, for the register, and when the regret is set to 1, the data will read into the register file. And RW just will determine which bit in the register file you will read to, and bus W will be stored into the register specified by RW. And this instruction is on the negative clock edge. And so for the read instruction, that should be happened when regret is 1 and it is a negative clock edge. And our register 31 must always read 0. So for this register file, just for this 31-bit, actually this should be the 32-bit because it is a 32-bit address. This the 31 bits should always read 0. Just kind of you can leave it as blank. We don't write the 31 bit. We don't write bus W into the 31 bit. And data from the registers will be sent on bus A and bus B, and RA determines which bit you want to read in the register file, and will be read as bus A. And RB will determine in the register file which bit to read as bus B. And RW is RW will determines which bit to write as just we will write bus W into the register file. And okay, this delay of 2 should be for the bus A and bus B, because bus A and bus B is kind of read instructions. For the if you assign the bus A and bus B, should have a delay of 2. And when you write at the falling clock edge, there should be a delay of 3. Just for this register file, you can understand like this. When the regret is 1 and we write bus W into the register file at the falling clock edge, and for the register file, RA and RB will determine just which bit we need to read as bus A and bus B, and bus A and bus B will output with a delay of 2. Okay, for question 3. After we have designed the register file, we provide a test bench for that. Yeah, we can use this test bench file to make sure if we design this module correctly. And if it's correct, and we need to modify it, we need to edit this test bench file. We need to just write the test cases following this following this table. If you want to write this table, actually you need to we gave the input RA, RB, RW, reg write, and bus W. And for the output, bus A and bus B, you need to understand how register file works first. And for each input, you need to pre-calculate the output for bus A and bus B, and write them into the test bench file. Just replace the given test bench file test cases with these inputs and your pre-calculate outputs. Then after you finish the test bench file, just run the simulation for the register file module and test if you just pre-calculate the outputs correctly. Okay, that's all for Lab 8. Thank you.